Hello students, so welcome to the session. In this session we are going to discuss about introduction to single linked list. In this we are going to learn about how to create new node in single linked list. In our previous classes we implement stack and queue ADT using arrays. From this lecture we are going to learn about linked list concepts and we are going to implement same stack ADT and queue ADT using linked lists. So, overview of presentation. So, first we are going to learn about definition of single linked list. Then we see the advantages of single linked list over the array. So, after that the creation of single linked list node in C programming. Outcome of this lecture, at the end of this lecture you all are understand how to create single linked list node in C programming. So, what is single linked list? Okay. So, before going to the topic, so we are going to discuss little more about arrays. So, what is array? So, array is a sequence of similar data items. So, for example, if I declare int a of 5, int a of 5. Now, how much memory we are going to allocate for this variable a? So, let us assume the size of the integer is 4 bytes. 5 into 4, 20 bytes of memory we are going to allocate in primary memory. So, let us assume this is the RAM. So, this is the RAM. Now, in this RAM we are going to allocate 20 bytes of memory. Let us assume this is the 20 bytes of memory. Okay. In RAM the memory is maybe one program is executing here, another program is executing in this place. Let us assume. Now, let us assume the size of this RAM will be 100 bytes. Let us assume. So, 100 bytes. So, this is 20 bytes, this is 20 bytes and the remaining, so this is 20 bytes, 10 bytes, so these are the 30 bytes. Okay. Now, in this 100 bytes, how many bytes are allocated for the program? 40 bytes. So, 40 bytes allocated for program. How many bytes is available? 60 bytes available. Okay. Now, if I declare int a of 10. Now, so what is the required memory? So, 10 into 4, 40 bytes. 40 bytes of memory we are going to allocate for this variable a. But here, so this is the 20 bytes chunk is available. So, 10 bytes is available, 30 bytes is available, but so continuously there is no 40 bytes. Okay. That is a disadvantage of array. For array the memory is allocated in continuous manner, but here the memory is 40 bytes are available, but the 40 bytes are not available sequentially. That is a disadvantage of array. Now, so how we overcome this problem means by using single linked list. In single linked list the data is organized using a node structure. Node structure. So, first we see the definition of single linked list. A single linked list is a fundamental data structure in computer science and programming. It is a type of linked data structure that consists of sequence of elements called nodes. Here in this problem we are going to allocate so 3 nodes here, so 2 nodes here and another 5 nodes in this top. Now, so we can link all these nodes. So, what is a single linked list? Single linked list is also a sequential data structure only, linear data structure similar to array. So, why we are using single linked list means single linked list is dynamic. Here each node, so for example, so this is the node, this is the node. So this node contains two parts. So one is data part, another one is next pointer. So this first part we are going to use to represent data. So this we are going to represent the pointer of next node. So for example, int a of 10, how many elements we are going to store? 10 elements. For example, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, so now, so after 10, we are going to store the address of 20 here. Here, we are going to store the address of 30. Here, we store the address of 40. Here, we store the address of 50. Here, we store the address of 60. Here, 70, 80 and 90 and 100. So this is single linked list. Single linked list also a linear data structure. It stores the elements in linear order using nodes. Each node have two parts. One is data part, another one is next node address part. Now, so this data can hold the actual information. Here the 10, 20, 30 are the actual information or value you want to store in the node. And this next pointer, this is the address part. Now, so for example, address of 20 is 150. Here we are going to store 150. Okay. Now, next pointer. So this pointer we call as a next pointer. This part is reference or link to the next node. In the sequence, it essentially points to the node that follows the current one in the list. Now, the 10, after 10, the next number is 20. So, we store the address of 20 in pointer in this next pointer. Okay. So, this is the definition of single linked list. What is single linked list? A single linked list is a linear data structure. In the single linked list, we are going to organize the data using a node. That node contains two parts. One is data part, another one is address part. Okay. So now we see advantages of linked list over the arrays. Now the first advantage is dynamic size. Dynamic size. So one of the most significant advantages of single linked list is that they can easily change in size during runtime. So for example, I want to store 5 elements using array. Now I declare like this, int a of 5. Now I want to store same 5 numbers using linked list. Then I am going to allocate the memory by using MLR function, allocating the memory dynamically. So dynamic size means they can easily change in size during runtime. Now int a of 5, how many numbers I am going to store? Only 5 numbers. If it is a linked list, we are going to store more than 5 numbers also. Okay. So memory allocation flexibility, here 5 numbers. If we are using linked list, then we are going to store 4 numbers or 3 numbers, or if I want 10 numbers, then I am going to increase the memory. So that is a flexibility, memory allocation flexibility. In an array, memory is allocated continuously. In linked list, nodes can be allocated dynamically. So which can reduce memory wastage if you don't know the exact size of your data in advance. Okay, if I don't know the data elements, how many data elements we have, then in this case we are going to use single linked list. If you know the exact data elements, for example I am going to read only 10 elements, then we are going to consider array. So no need for reallocation. Array may require reallocation and copying of elements to accommodate more data when they reach their capacity. So what it means, for example, int a of 5, now I store only 5 elements. If I want to store another 4 elements, then I am going to reallocate memory int a of 9, and I copy the previous 5 values into new array. After that we are going to store the remaining 4 elements. But in linked list don't have this issue. So as you can keep adding nodes as long as there is available memory. If the memory is available in the RAM, then it allocates the memory. Okay. So reduced fragmentation. So linked list can help reduce memory fragmentation as each node can be allocated individually, unlike arrays where you allocate a large block of memory. So for example, int a of 10,000. So 10,000 we need 40,000 bytes, but the memory may or may not be available. So because of the fragmentation, the memory is not available at one place. For example, this is the memory. So here there is 20,000 bytes is available, and this is utilized by another program. Maybe here there is another 30,000 bytes is available. Now if you declare int a of 10,000, it requires 40,000 bytes. Actually 50,000 bytes are available in memory, but we are not able to use. So how we are going to overcome this means by using linked list. Okay. So these are the some of the advantages of linked list over the array. So what is the disadvantage? The disadvantage is here extra memory to store the address of next node. Okay. So that is the disadvantage of linked list. So how to create node in linked list? Okay. Now if I declare int a of 1, so what it is? I am going to create one array that holds only one data element. Now this is the data element. If I allocate a equals to 10, now 10 is stored in this memory area. In linked list also similar. It is also a node, but this node contains 2 parts. So how we define this node means by using structures. Here we are creating one node using structure. Now the node, this is the node, contains 2 parts. One is data part, another one is pointer. This is the pointer. Now this data is maybe integer, float or character. Here I am taking this data as a integer. So this is the pointer. So what is the type of the pointer? It stores the address of another node. So the data type of the pointer is node. Okay, so how I define this node means struct node. This node have 2 parts. One is data part, another one is next part. So this is the data and this is the next part. The data type of data is integer. The next part data type is node type. Why? The address of node we are going to store here. So we consider this data type of next is node here. Okay. So this is the structure of the node. How we are going to define the structure of a node. Now we see how to create node. So for example, here I am assigning data a equals to 10. Now the memory is allocated. In that memory 10 is stored. Now similarly here the function name is create node. Create node 10. Now what is my intention? I want to store this 10 in a node. Okay. Now the create node. So what happened? Struct node, this is the new node. One new node is creating, new node equals to struct node MLR size of struct node. Memory for this node, that much of memory is allocated using MLR function. Now one node is created and this node name is new node. Okay. So now this node have some address. Let us assume this is the 1001 is the address. Now so what is the new node address? 1001. Now new node equals to 1001. Now new node equals to null. What it means? If the node is not created, then it return, in this case it returns 1001 address. If the memory is not available, then it send null to the new node. So first we are going to store the data, we are going to check the node is created or not. If it is not created, then we are going to display, so memory allocation is failed and exit. Okay. In this case, the node is created and this will be false. Okay. Now this is the node. Now so 10 is the data. Now new node dot data. So this is the new node dot data equals to 10 here. So 10 is stored here, and the next pointer will be null, and we return this address 1001. Okay. So this is about how we create node in single linked list. So this is very important. In next class we are going to learn about insertion. Whenever we insert any new node, we are going to create the node. At that time we are going to call this function create node only. Okay. So create node means one node is created in memory and the data part is assigned in data place, and the next part is initialized with the null and return this new node address to the called function. Okay. So this is about say create node. So summary of this lecture. In this lecture we learn about a single linked list definition. A single linked list is a fundamental data structure in computer science and programming. So this node have two parts, one is data part, another one is next part. In next class we are going to learn about how to insert nodes in single linked list. Okay. If you have any doubts, so place your doubts in the comment section. I will answer all your doubts. Thank you.